Yeah. Yep. Okay. So you hear, but no, but you hear it from OBS.
I hear from OBS.
You hear it from OBS, yeah.
Yeah.
But if it's going OBS, then you should be okay with the stream. Okay. No, Adwick, go to yeah, go to the
I can
thing.
hear it from YouTube now.
Oh, you hear it from YouTube? Did you hear what I was saying? Did you hear what I was saying like a while ago? It's probably gonna take a bit.
Yeah, it's fine.
Okay,
Like
then
the
stop it.
coming through though. So it's
I gotta stop it.
okay.
Systems Showcase. Please take your seats as we will begin shortly. Good evening, everyone, and welcome to the Monash Uncrewed Aerial Systems Showcase Night. I'd like to begin by saying that Monash UAS acknowledges the Bunurong people of the Kulin Nations, the traditional custodians of the land on which we gather here tonight. I'd like to pay my respects to their elders, past, present, and emerging. This always was and always will be Aboriginal land. Now, my name is Sumi, and I will be your MC for tonight. I'd like to thank you all for being here. Our sponsors, faculty members, industry partners, friends, family, and fellow students. Your support is what enables the team to push the boundaries of what student-led engineering can achieve. Tonight's showcase centres around a single theme: storm response. When a major storm hits, the challenge isn't just the weather, it's what comes after. Infrastructure is damaged, access is limited, and critical decisions must be made, often with incomplete information. In these moments, speed, reliability, and situational awareness matter. Everything you'll see tonight has been designed around that problem. Our goal at UAS is to demonstrate how uncrewed aerial systems can operate in these high-pressure environments, supporting response efforts when conditions are harsh and every minute counts. Now, to formally welcome you and introduce who we are, please join me in welcoming our 2026 team lead, Ethan Liberman.
Thank you, Sumi, for that introduction. Welcome, everybody. My name is Ethan, and I'm the team lead in 2026 at MUAS. Alongside me are James Morton, my chief engineer, and Ollie Bilston, our inaugural chief operating officer, whose presence has been invaluable, as well as a dedicated, brilliant management team who have the pleasure of listening to me talk loudly and often. Until you sit on upper management, you never really have a sense of the momentum of your team. Since stepping to this role, I have come to greatly admire the frankly backbreaking work that prior upper management teams have put in to get MUAS to the position it is in today. It is no secret that we were put into a difficult position following the coronavirus pandemic, but I'm proud to say that yearly incremental improvements have culminated in a second consecutive international campaign, and the gravity of that statement is not something to be overlooked. I would like to specifically thank Nick and Tom, last year's team lead and chief engineer, for their mentorship and their sage advice, as well as earlier upper management teams Dilshan, Will, Ava, and Jordan, who laid the foundation of our present success. Looking at the room tonight, it's amazing to see how far UAS has come. 15 years ago, a handful of students with a shared curiosity decided to compete at the Outback Challenge. They weren't experts, they didn't have polished systems. What they had was persistence, creativity, and willpower. That same spirit defines the team today. MUAS has now grown into a force of over 100 students with a diverse range of skills throughout all disciplines of engineering and more. Every year, we take on harder challenges, design more complex systems, and push further into real-world applications, all driven by our mission statement: to showcase the humanitarian potential of remotely piloted aircraft systems while educating and inspiring the next generation of engineers. This year, we focused on a particular aspect of our statement and sought to answer one question: how can uncrewed systems perform when conditions are at their worst? In Australia, we have the privilege of experiencing both ends of the natural disaster spectrum. In the southeast, we brave deadly bushfires, and our thong-wearing, rugby-playing northern counterparts suffer immense cyclones. Communities are left isolated, infrastructure is damaged, and environmental hazards emerge rapidly. Emergency services are forced to operate with limited information, often racing against time to protect lives and restore stability to the community. A glance at the official search and rescue fees and charges reveals that the cost to rent a rescue helicopter is up to $10,000 per hour. The hourly cost of a drone, $150. In moments of strife, technology becomes a critical enabler of recovery, resilience, and discovery. Storm response is not only about restoring what was lost, it's about rebuilding smarter, acting faster, and protecting for the future. And that is exactly what you will see reflected in tonight's showcase. You'll hear from each section tonight about how they intend to design, build, and operate uncrewed aerial systems to answer this question and perform on the international stage. To introduce those sections further, please join me in welcoming Ollie to the stage.
Good evening, everyone, and thank you, Ethan. Last year, MUAS did something it had never done before. We packed up our aircraft, flew across the world to Hamburg, Germany, and competed on an international stage for the first time in the team's history. That achievement was largely due to the incredible effort of last year's management team, and the work they put in hasn't ended when the year did, and it's what we're continuing to build on right now. My name's Ollie. I'm MUAS's Chief Operating Officer for 2026, and tonight we're here to show you what that next chapter looks like. I'd like to introduce you to some of the people helping make that happen alongside me. Aerostructures, led by Chi and Lachlan, form the physical backbone of our aircraft. Design, structural analysis, computational fluid dynamics, and in-house manufacturing, they develop the airframes that allow us to perform our mission. Avionics, led by Yagita and Isaac, are where the aircraft gets its intelligence. Electronics, sensing, autonomy, search and rescue systems, they're the reason our aircraft can do so much more than just fly. Flight operations, led by Alistair and Alexi, are where our engineering projects meet the real world. Fleet management, integration, ground station operation, testing and mission execution, supported by our lead pilots, Tom and Ardwick. They're the ones responsible for putting us in the air. Propulsion, led by Julian and Oliver, developing our performance beyond what you can find off the shelf. Everything from custom motors, inverters, propellers, and more. They're improving our efficiency and our performance, giving us a competitive edge that money can't buy. And finally, the section that keeps everything moving, operations, led by Sumi, with Connor as our finance manager. From sponsorships, recruitment, logistics, outreach, and marketing, this team ensures a smooth running of MUAS while supporting our technical sections. Tonight, you'll hear from each of these leads about their work and achievements throughout the year. So please give me a round of applause to the students who make this team possible.
Thank you, Ollie. Before we hear from our sections, please welcome to the stage our former team lead, Nikhil Pokharel, to reflect on our achievements last year.
Good evening, everyone, and thanks to the team for giving me the chance to reflect on an incredible year. This time last year, before I came up here, a fellow team member said to me, "Nick, you should put on your jacket." And I replied with, "Why would I put on my jacket? It's 30 degrees outside." To which she replied, "Because Nick, your back is drenched with sweat." Safe to say I was well and truly nervous. Why was I nervous? Yes, in part, you all have very terrifying faces. But mainly I was nervous because I was standing up here about to make a promise. A promise that despite what was thrown at us, Monash UAS would compete at their first competition in a very, very long time, and do so proudly. I'm pleased to say that we fulfilled that promise. I'm sure you can imagine the road was far from smooth. We faced many delays and many setbacks. Of course, in hindsight, we could have done things faster, we could have made better decisions, and we could have tested for longer. But the hurdles we faced, we turned into learning opportunities which we leveraged to ensure competition readiness. The external deadlines of competition meant that discipline was non-negotiable. Discipline in terms of ensuring safety and flight readiness. In 25, we implemented strict engineering checks on our projects before making the commitment to test our creations in flight. The outcome meant that instead of rocking up to a flight day and spending most of it, if not all of it, debugging, we could get there and be up in the air within a couple of hours. A practice which I'm glad to see the team has not lost. Come August, 16 of us jumped on a plane and arrived in Hamburg. And soon after, so did the Peregrine aircraft. That one up there. But not without 3 days of negotiating with German customs. I was warned by our German supervisor that the locals weren't known for being particularly cheery, but I definitely wasn't prepared for the German border force. After assembling our drone in a small space, competition day arrived. And the aforementioned improvements to our processes once again became evident. On flight days, we were consistently ready hours in advance of other teams. And I was proud to see Monash UAS students showcasing Australian mateship, lending a hand wherever we could. I even saw a couple of our members helping other teams set up their flight controllers. The competition itself was a roller coaster of emotions. After the first day of flying, our drone suffered a bad crash. On any other day, that plane was a total write-off. However, that night, our determination to keep flying motivated what I can only describe as the most incredible feat I have seen during my time on this team. Overnight, we got the aircraft back together, despite damage to wings, fuselage, and tail. We were able to repair the aircraft to a state almost identical to the one it was in before it even crashed. The next day, we flew again. Now, while yes, the team did not walk away with a podium finish, we were proud nonetheless. We now have the discipline and the confidence to excel. For me, for the team, success is not defined by one competition. It's defined by upwards trajectory. Between 2020 and 2024, we rebuilt our fleet of aircraft. In 2025, we attended and placed at an international competition. And in 2026, well, I won't make promises on behalf of the new team leaders, but I have no doubt they will continue the upward trajectory. Thank you.
Thank you, Nick. UAS has undoubtedly come so far in the past year. Now, to hear more from our sections, please join me in welcoming our 2026 section leads.
Good evening, everyone. My name is Lachlan, and alongside Chi, we are MUAS's 2026's Aerostructures leads. On our airframes, the responsibility lies with Aerostructures to design and manufacture a robust yet efficient foundation upon which the aircraft can perform its mission. In more tangible terms, this is the fuselage, the wing, the control surfaces, the tail, the landing gear, and all of its mounting systems. In between, the product of extensive design and analysis to get us into the air, keeping us in the air, and bringing ourselves down safely, reliably, and efficiently. In 2025, Aerostructures completed the design and manufacture of Peregrine's airframe. It is on board this airframe that we debuted a multiple of new designs, including a custom composite spar, composite control surface hinges, and a fully carbon monocoque fuselage. In 2026, we have taken the learnings from Peregrine and NSC to simultaneously produce two clean sheet airframes. Redback, a multi-rotor representing MUAS's entry to the SUS 2026 competition, and Karawang, a developmental fixed-wing airframe built to the IMEC-E competition rule set, intended to further Aerostructures design and techniques. Thanks to the effort of our dedicated members, the past year has seen Aerostructures leap forward as a section, and with Redback and Karawang set to fly, I hope you all will join me looking onwards to the future with excitement. Now please welcome Soda to talk a little bit about our sponsorship of LEAP.
Hello everyone, I am Sota and I'm the current FEA Simulations Lead of MUAS, and I would like to take a moment to thank all of our sponsors for the team, as we would not be where we are today without their support. Of the multiple sponsors we are grateful to have, I would like to focus on one of our platinum sponsors, LEAP Australia. LEAP is a leading provider of advanced engineering software and technical support across Australia and New Zealand. They have over 30 years of experience in digital engineering, having over 60 staff across their 6 offices. Their sponsorship has enabled our team to access professional-grade engineering software used in the aerospace and high-performance engineering industries. Out of the many tools that LEAP has to offer, our team heavily relies on Creo, Ansys, and Windchill. These 3 form an excellent environment and the key backbone of our digital engineering processes. As the FEA lead and a member of the Aerostructures section, I have had the great opportunity of using these tools extensively with my peers, and the impact on our workflow has been significant. Creo is our primary computer-aided design, or CAD software. Every structural component, surface, and integration interface of our aircraft has been designed and developed using Creo. Creo allows us to seamlessly create and integrate our designs and give us precise control over the geometry of our model, which is essential for an efficient and high-performing drone. For many of our recruits, their first experience with software used in the professional industry tends to be Creo, which is a valuable experience and an opportunity that was made possible through LEAP sponsorship. As we are a student team, you may be wondering how we manage our CAD data across multiple students. This is where Windchill comes into play. Windchill is a CAD data management tool distributed by LEAP, which allows us to securely manage, share, and collaboratively work on our components without being on the same device. Our team heavily relies on Windchill for CAD data management, version management, and team collaboration. In a large multidisciplinary team like ours, Windchill is an essential component in efficiently managing configuration control, avoiding integration issues, and maintain traceability throughout our design cycles. The parts created on these software are validated using ANSYS, a simulation tool that is given to us through LEAP. ANSYS allows the team to perform highly detailed physics-based simulations with a large degree of flexibility. The primary simulations conducted in the team include structural analysis, or FEA, and aerodynamic studies, or CFD. With the team's limited budget and tight timelines, it is crucial that our parts perform as intended. ANSYS allows us to do deep investigations and analysis of our designed parts to ensure they work as intended before they are manufactured, and have helped our team significantly and has helped identify potential failure or optimizations at early stages of our design cycles. ANSYS has enabled our team to make informed decisions based on real physics and math rather than intuition alone, greatly improving our capabilities and quality of final products. So up here is an example of the digital design process used with LEAP's ecosystem. The initial design is drawn, and a simplified version of the CAD is created on Creo. This design is further refined and then imported into ANSYS to investigate the structural strength of components as well as aerodynamic characteristics. Then the internal components are also created on Creo to create the final product. This simple and streamlined process gives us an excellent and well-refined design using the tools provided by LEAP. Overall, the industry-grade software ecosystem provided through LEAP sponsorship has enabled our members to gain hands-on experience of real engineering and operate with professional engineering workflows, bringing classroom theory and real engineering practical design work together. LEAP sponsorship contributes largely to our team's ability to design, simulate, and collaborate within the team. On behalf of everyone in MUAS, I would like to sincerely thank LEAP Australia for their continued sponsorship and support of our team, and appreciate their investment in the next generation of engineers. Thank you.
Thank you, Soda, and good evening, everyone. My name is Isaac, and together with Yugita, we are your avionics leads for 2026. Avionics brings our aircraft to life. We're responsible for the design and implementation of the electrical hardware and software that ensures the aircraft can navigate, communicate, and operate safely in flight. It serves as the aircraft's brain, giving it the intelligence to sense and interpret its surroundings. With that intelligence, it can make autonomous, informed decisions in real-world conditions. Over the past year, our section has made significant progress on our avionics projects, from payload delivery to AI object detection, advancing our capabilities to perform real search and rescue missions. Some of the notable achievements include the development and successful in-air testing of Project Lifeline, our payload deployment system for SUAS, flying at NFC with our custom-built power distribution board, and the demonstration of static inner object detection algorithms, allowing our aircraft to detect and avoid objects in real time. It's been a very exciting year for avionics. We're both incredibly proud of the effort every one of you has put in, and we can't wait to see what you can all achieve in 2026. Thank you.
So today we're talking about projects. We've got the vision ecosystem, which is designed to map various terrains and detect, locate, and classify multiple objects of interest. And by utilizing a well-trained computer vision model, alongside an optimized pipeline, we are able to streamline this process in real time.
Lifeline, our payload delivery system, is designed to deploy life-saving equipment to patients in need. Currently using a tailored delivery system with braking control speed.
Showing the collide with foreign objects while we We have currently implemented rudimentary obstacle detection, off-board control, and course path planning. We are currently working on predictive controller to ensure our avoidance trajectory is feasible under a dynamics model of the drone.
Mission management is our custom graphic user interface, designed to integrate data and controls for all these systems seamlessly, so that our project and flight operation teams at ground control can access everything they need in a concise and clean format. Stack consists of the hardware and software controls, signals and systems for our custom-built aircraft, including the previous and current competition aircraft and other testing platforms.
Good evening, everyone. My name is Alistair, a co-leader of the Flight Operations section alongside Lexi for 2026. Flight Operations is the last line before ensuring our aircrafts are flight ready. We ensure all systems are fully integrated, verified and operating as intended, allowing design to move from concept to reality. Our in-flight responsibilities include operational ground station, analysing telemetry in real time, and piloting the aircraft. Included in flight operations are both MUAS's lead pilots, Tom Merchant and Ab Gosh. Over the course of 2025, flight operations has doubled in size, going from just 8 dedicated members to 16 passionate engineers. With that growth came a larger capacity to take on technical projects, including both our new fixed-wing aircraft, the Ibis, and a revised competition-grade ground station. This year we developed and deployed a new ground station platform, allowing for accurate analysis and scrutiny of in-flight data. We also introduced streamlined flight day processes, clearly defining roles across safety officers, ground station operators, and flight day coordinators to improve flight day efficiency and ensure we are testing for longer.
We plan our flight days 3 months in advance so that we can set clear deadlines and aircraft cut-offs for the whole team, and ensure that we maximise our time airborne instead of airside. The week leading up to the flight day, we coordinate pre-flight safety checks, which are done by every section on the aircraft. Flight operations conducts ensuring that every aspect of the aircraft is ready for a successful flight.
The safety of our team members, the public, and property are paramount at all flight testing we conduct. This year, we have overhauled our flight day processes from the ground up. The flight day safety officer, who leads the safety crew, are the only ones authorised to deploy and disarm the aircraft. All of our aircraft are equipped with power isolating emergency stops and software safety measures.
No flight day would be possible without the help of the entire team. Once all of the safety checks have passed, the pilot works with the safety crew and ground station operators to maintain a safe and successful flight. Success or failure, we review our footage, logs, and other data from the flight day to determine how we can improve our aircraft and our procedures.
My name is Oliver Basili, and together with Julie Nociara, we are your 2026 propulsion leads. At its core, propulsion answers a very simple question. How do you get stored energy and turn it into the thrust required to effectively lift, keep an aircraft in flight, and have it land safely? You see, producing thrust in of itself is simple, but when you have a look at the iceberg of underlying mechanisms that allow that statement to hold, you see that what seems like a simple question becomes a lot more convoluted. Doing so in the most efficient and effective manner possible for your aircraft becomes a task almost no team can achieve. And this holds true without even considering weather, which we all know as Melburnians is very unpredictable. Wind, rain, lightning, birds, temperature, hail. If you somehow did make an aircraft that achieves your aircraft's, if you somehow did make a system that achieves your aircraft's requirements in the most efficient and effective manner possible, you're most definitely not adhering to all of these factors. So this is where the approach that we take at the propulsion section comes into play. But before telling you what our goal is, I want to look back to when the propulsion section was founded. You see, in 2024, before I had even joined the team, members of the propulsion section, who, well, frankly, know a lot more than I do, had this discussion around how we would actually achieve the most efficient flight possible. How to get as close to 99% efficiency, and how to be the best section we can possibly be. As you all know, there are a lot of commercial off-the-shelf components, but these components must fit many different builds to be marketable, essentially sacrificing efficiency at specific use cases in the process. And save for getting a drone into the air to take photos, we're a competition team, and breadth of use serves no purpose to us. So the idea sparked. Why don't we create our own custom in-house components? And that's exactly what we started to do in 2025. We manufactured multiple custom in-house propellers. We completed the electromagnetic design of our custom motors. We finished the design of our custom electronic speed controllers, which are now scheduled for design review this week. And we manufactured 2 versions of our CSU, which essentially gives our propellers variable pitch, allowing them to change their angle mid-flight, making sure our system is always operating at the most optimal point on the airspeed efficiency curve. And this year, we plan to finish manufacturing for all of our components and place them on one of our 3 main aircraft's IBIS, our flying thrust test stand. That way we can get valuable data for each of our components and redesign, reiterate, and remanufacture for future competitions, which you'll hopefully see if you come to future showcases. Thank you all for coming, and I hope you have a lovely night. We're now going to watch a video on some of Propulsion's achievements in 2025. Thank you.
That's exactly what operations have been dedicated to in the past year. From hosting workshops with our fellow engineering team, RoboGirls, to mentoring students at John Monash Shine School, we have worked hard to inspire and encourage younger generations to feel confident stepping into engineering. Beyond outreach, operations is a core section that keeps UAS running, from managing sponsorships and other partnerships, events, logistics, and recruitment. Also, our technical team can focus on building and flying. Our marketing sections have also worked tirelessly in producing some of the best content in recent years to showcase our journey at NFC as well as our other proud achievements. Supporting this team is incredibly rewarding, and we're excited to keep building the UAS community. Thank you.
Thanks, Sumi, and good evening, everyone. My name is James Morton, and I'm the Chief Engineer for 2026. Now, before I speak to our competitive ambitions for the year ahead, I'd like to touch on the progress the team has made over the last 12 months, advancing our engineering processes. Firstly, detailed on-location pre-flight checklists and workshop flight-ready checklists are now standard across all of our aircraft. These checks are informed by real-life aviation practices, and the detailed scrutiny involved supports us to maximising our flight time and preventing delays amidst a developing testing landscape. Secondly, we have established a new point of certification and documentation for all of the components and systems on our aircraft. We refer to these as engineering authorities, and they help us to ensure that any component or airframe has been thoroughly tested and that supporting documentation is well organised. Now, to the year ahead. As you well know, last August, Monash UAS travelled internationally to compete for the very first time. And what can I say? We are hungry for more. Once NFC was behind us, we quickly switched gears and set ourselves a new goal. The Student Unmanned Aerial Systems Competition 2026, or just SUAS for short, set to run in September this year in Tulsa, Oklahoma. Running annually since 2003, SUAS is a prestigious US drone competition that has grown to host up to 50 teams from around the world. This year, the theme is Storm Response, a humanitarian cause close to our hearts. The mission premise is simple. A powerful storm swept through, leaving behind unknown destruction and potential environmental hazards. Uncrewed aerial systems are deployed to demonstrate how coordinated action can turn disaster into resilience. The mission itself has 3 key stages. Firstly, the flight vehicle must autonomously traverse a series of waypoints, mimicking the need to survey key locations in a disaster response context. Secondly, given coordinates defining a search area, the drone is required to produce a high-quality aerial map, simulating the role in damage assessment and reporting critical information to authorities. Thirdly, within the search area, the aircraft is required to correctly identify and deliver a water bottle and a beacon to a mannequin and a tent respectively, replicating the role a drone plays in delivering key supplies to first responders and impacting civilians. In addition to these tasks, the UAS will be scored on its flight endurance, how many times it can complete the course, and how many payloads it can deliver. It's designed for rapid response. Can the system fit into checked luggage, carry-on or personal luggage? And its operational efficiency. How many ground operators are required to deploy the system? We chose to focus on maximising our scores in the mapping and payload delivery tasks, with attention to operational efficiency and design for rapid response. This blend of avionics and functionality and transportability is best suited to a multi-rotor platform. With that said, I can now reveal that our entry, dubbed the Redback, is a fully in-house 8.5 kilogram quadcopter platform. Now, without further ado, let me introduce you to our 2026 SUAS aircraft, the Redback.
Thank you, James. Storm response requires individual sections tackling the challenge from a different perspective, from airframe resilience to onboard intelligence. But success in a mission depends on more than just individual contributions. It relies on collaboration, sections working together to deliver a system capable of performing in times of need. To show how this comes together in practice, we will now hear from our section leads as they share how their work contributes to our SUAS mission objectives.
To be able to complete our storm response mission, our airframe needs to be built to prioritize reliability, robustness, and operational endurance. Our aerostructures design directly addresses these needs by ensuring the frame remains rigid, damage tolerant, and capable of protecting our critical systems. From a structural perspective, our frame is made predominantly out of a series of carbon fiber plates, which provides a strong and stiff platform to mount components to. Multi-rotors are known to experience significant loads at arm roots when in flight. We reinforce these primary load paths by carefully adding joint interfaces to minimize stress concentrations and reduce the risk of fatigue or fracture over repeated flights. With multiple high-speed motors, vibration can degrade cameras, interfere flight controllers, and reduce component lifespan. Our structure is designed to limit flexing and dampen vibration transmissions to sensitive avionics. This directly improves the quality of our imaging and mapping, as well as the reliability and smoothness of our flight during storm response missions. We learned a lot from our first version of the Redback airframe, one of those things being that we could further reduce the overall weight of the frame. The lighter the airframe, the less work our motors have to do, which increases our endurance, earning us more points. This has resulted in aerostructures iterating on the airframe, reducing the overall size and shape, allowing us to create a fully integrated Redback V2, which collectively houses our avionics, propulsion, and flight systems for our September campaign at the SUAS competition.
To achieve the goals of the SUAS competition and create a drone capable of completing a storm response mission, our various projects have been developing solutions that work together to address these issues. Lifeline modified and finalized their payload delivery system to deliver a water bottle and beacon to a person in distress with a braking system to ensure safe speeds. They've been able to successfully test this system and are now looking at adapting to different types of aircraft with non-tethered deployments. Vision aims to stitch together photos from the drone's gimbal camera to create a cohesive and accurate map and differentiate people in distress from other features on the landscape. Outside of competition scope, this system can also aid in remote damage assessment and environmental hazard monitoring in complex terrain. In the competition, we will be sharing airspace with other drones, and it's vital for everyone's safety that we are capable of flying around them. Detect and Avoid integrates with our flight control systems to send alternative pathways that avoid foreign objects while our drone is completing a set mission in air. All of these projects interface together with the help of our mission management and stack teams that aid in software and hardware integration and development on a larger scale than we've attempted in recent years. Together, all these projects aim to fulfill the competition mission and create a solid foundation to expand all designs to reliably aid in search and rescue missions.
For flight operations, SUAS demands far more from the section than any prior competition. The work we do, ensuring every component of the aircraft works together in harmony, testing aircraft for peak performance and efficiency, overseeing final safety and integration checks, and conducting safe and consistent flight testing will be vital for our success come September. We'll be addressing the demands of this mission with a revised ground station setup, featuring redundant computer systems, a new telemetry pipeline with improved bandwidth and reliability, and working closely with our friends in avionics to provide a single ground station operator the tools that they'll need to coordinate the SUAS mission all on their own. Furthermore, the amazing projects that Yogita has discussed will require many in-flight tests to perfect the SUAS mission requirements, even when the competition airframe is grounded for overhauls or repairs. Flight operations will enable these tests using our fleet of additional aircraft. Hydra and Kraken, our heavily modified, off-the-shelf Hexa and Octorotors, will provide regular and consistent testing opportunities for these projects. Flight operations are also commissioning 2 new aircraft on the road to SUAS. The Mosquito quadcopter, a small-scale testing platform for experimental autopilot procedures that we'll need to implement to satisfy the autonomous flight procedures of the competition, and the Firefly tricopter, an intentionally unstable aircraft intended to help us hone our ability to order the chaos of multi-rotors and apply our learnings to the competition airframe. Thank you.
Storm response poses several challenges to the design of an effective propulsion system. This operation demands endurance, maneuverability, and heavy equipment that needs to be able to perform in unfavourable conditions. With these factors in mind, we have designed a Quad X configuration aimed to fly long-duration missions with emergency supplies and advanced avionic equipment. This configuration lends itself to storm response due to its form factor, carry capacity, ability to maneuver, and hold location. To get the most out of our system, we are going to use our own in-house designed and manufactured propellers to leverage the most efficiency possible, maximizing our flight time. These propellers will be the next advancement from our competition propellers used previously and will be integrated onto version 2 of the Redback. Our newly developed design and fabrication processes utilizing additive manufacturing, resin infusion, and novel processes allows our designs to be turned into reality rapidly and on demand. This has helped make it possible to outperform the off-the-shelf components by saving on weight and optimizing our designs for our specific mission objectives. With improvements in our propulsion system, we are able to go further, faster, and without worry for broken propellers holding up flight testing. Our power system was designed to take advantage of readily available 6S batteries to ensure that no specialist equipment is needed in an emergency response. We have designed a system that integrates 6 of these batteries, allowing us to replace and recharge easily anywhere. We are, however, still in the early testing phase of our current system, and we foresee several challenges that we are excited to overcome. While multirotors do not traditionally lend themselves towards long-distance flights, their advantages make them ideal for the upcoming competition. A highly efficient system is going to be necessary to perform at the upcoming competition. The propulsion system is going to make or break our operation, and I look forward to the challenge and our success. Thank you.
Good evening, everyone. My name is Sanjeevan Rajasega, and I'll be responsible for leading MUAS's marketing team for 2026. As you can imagine, storm response missions aren't only defined by the aircraft in the air. They're also driven by the vision and coordination that makes flight possible in the first place. For SUAS, this means coordinating logistics, partnerships, and resources so that technical development can move forward without interruption. From securing sponsorships and managing budgets to organizing travel equipment and compliance requirements, operations ensures that the team can confidently represent MUAS on an international stage. A key new initiative this year is the development of a targeted website specifically designed for the competition beyond the flight of the aircraft. This has never been done before and pushes us to evolve beyond purely technical performance. Our revamped website will centralize technical documentation, showcase our mission strategies, highlight team structure, and present our deliverables in a clear and professional format aligned with the competition judges' expectations. This ensures we are not only technically prepared, but also strategically positioned in a way to communicate our work at the highest level. Beyond the competition, we support long-term growth by engaging with the broader student community, showcasing our mission and encouraging new team members to become part of MUAS through various recruitment campaigns and university initiatives. At the same time, our outreach programs also strengthens connections within the industry and wider community, building long-term relationships that help sustain the team's progress beyond competition. Finally, our marketing team is focused on reshaping how MUAS is perceived across the student community, expanding our visibility beyond the engineering space. By capturing the competition journey from preparation and testing through to deployment and its outcomes, we showcase the innovation, dedication, and values that define MUAS. Storm response missions are ultimately about the coordination under pressure, and operations as a section reflects that principle within the team itself. By maintaining the structure behind the scenes, we enable every technical section to focus on designing, building, and ultimately flying our aircraft. Thank you.
Tonight, you've heard from each of our sections about how their work comes together towards a shared mission. We've developed a short render that envisions how Redback will perform at competition this September in Oklahoma. Thank you to Chi for that wonderful render. Often when I brag about MUAS to my friends, or really whoever will listen, the assumption is that we're paid for our work, since we harness a professional software suite, manufacture most of our platform in-house, and have access to high-grade materials. In fact, a crucial factor in our success is the continued support of our sponsors. The contributions that these companies make enable us to achieve our mission to inspire and educate the next generation of engineers. Whether your contribution is in the form of software, materials, or technical expertise, your contribution is invaluable to us, and we are very grateful. Before we conclude the presentation part of the evening, I'd like to extend a thank you to a few groups. First, I'd like to thank each and every member of Monash UAS. Your hard work does not go unnoticed by your project leads, your section leads, or by upper management. The fruits of your labour are sitting here and upstairs, waiting to be shown off to your friends and family. I'd also like to thank those friends, family, esteemed MUAS alumni, and members of other student teams who braved the cold weather to attend tonight, or who are watching online. Your presence means everything to us. To the members of the Monash faculty and the Monash Student Teams Initiative, our work here would not be possible without your support. I'd also like to extend a final thank you to our operations team who coordinated tonight. If we'd like to please give them a round of applause. Ladies and gentlemen, I would like to now invite you to head upstairs for some light refreshments and to gander and gawk at the amazing work that we've been doing over the past year. Thank you very much. Cool.